TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. My guest, Jon Turner, maintains the TypeScript package at Microsoft. Jon, welcome to Software Engineering Daily.
Yeah, thanks for having me.
What is TypeScript?
So TypeScript, in a nutshell, is a typed superset of JavaScript. It's really basically just the JavaScript language, and then we add two main components to that. The first one is an optional type system that allows you to get really good tooling, error detection, but it's like I said, it's kind of optional, so you can put it in where you want it, and then take it out where you don't want it, so it doesn't really kind of get in the way and gum up the works. And then the other kind of feature around it is that it's a transpiler. So it's taking like what we call ES6, which is the current version of JavaScript that was just recently ratified, and even future versions of JavaScript, ES7 kinds of features, compiles them down so you can run them in any browser, in Node, and kind of across anything. So it kind of does this dual path of type checking and tooling, and also transpilation.
Why is TypeScript useful to the average developer?
So it really fits into whatever you're trying to do with in your workflow. So if you need a transpiler and you need something that is letting you use the features from ES6 like classes and modules, you can compile those down and then use them today. If you want good tooling or good error checking, you may have a bunch of unit tests, but then once you write those unit tests, it's always nice to get like that extra bit on top of that. And type checking gives you kind of a little bit of extra confidence that you got it correct.
So for developers who are less familiar with dynamic versus statically typed language, so what is the advantage to having typed variables in the code that you're writing?
Sure. So in JavaScript, all programming languages are typed on some level. And that means that any value in that system, there is some shape to it that either the runtime system understands or the compiler understands. And so that's how it does its job. The most basic sense, you've got a number, and you can add these two numbers. When I put plus between two numbers, that means add. But without the type information, I don't know that. And so, for example, in JavaScript, if I do that between two strings, I get a concatenated string, right? And it's at runtime, it's looking at the types of those two arguments, and from that knows, okay, this is concatenation versus addition. So there's a runtime sense of what these types are. So what TypeScript does is it lets you, in a sense, lift that much earlier in the process. So you're not running the code, you're kind of annotating the code and letting an editor or a compiler check it for you ahead of time. So the runtime would be the dynamic style, and then the compile time or editor time frame would be the static.
What happens if I declare a TypeScript variable x as a number, and then I reassign x to a string, all in TypeScript?
Right, so that's totally valid JavaScript, right? So you can do kind of this reassignment, very flexible, dynamic style programming, and that's valid JavaScript. But in TypeScript, we have a bit of an opinionated sense of what makes sense and what doesn't make sense. If you say something is a number, and then you go and then change that to something that's completely different, that's completely not compatible, like a string, we think that's probably an indicator of something that you should either refactor. At the very least, you should be notified, well, that doesn't look very good. So that's where we start doing these kind of, in an editor, maybe squiggle underneath it so you can kind of look at it and dive in a little closer.
TypeScript does give users the option to leave their variables untyped, though. So why would a user sometimes choose not to use static typing?
I think there's a lot of power in the flexibility of the JavaScript language. So you can do mix-ins, you can do inheritance patterns, you can get even fancier if you want to, and kind of have these like ad hoc extensions. Those are really cool, and they're also kind of get further and further away from what a compiler can reasonably describe in the type system. I mean, sure, you can make your type system like really fancy and really elaborate, but then like only 10 PhDs in the entire world will know how to use this thing, right? And a type system is just a tool. And the more people that can understand and use the tool, the better the tool is. So there's kind of a natural fall off where you're like, okay, at this point, the static type system that kind of needs to get out of the way because there's something more interesting in a dynamic sense that I want to do, and I want to be able to do that.
So a typical JavaScript application would have to do, one that's not using TypeScript, would have to do type checking with verbose lines of code. You know, the JavaScript application could use the keyword type of, or you can write your own function to test if something is a number or test if it's a string. But each of these options seems like it's decisively worse than using TypeScript. When the application can move all of this type checking to a compilation step, instead of having to do all this type checking within JavaScript, the check only needs to occur once. You only need to check it in the compilation step. I mean, you have to check each time, you have to check each variable, but there's only one step and it's outside of the realm of execution. So does this summarize the big performance gains of TypeScript?
That's a great question. So the type checking that the compiler does, like you're saying, is only at compile time. After that compiles, all that type information gets erased out of the code, and what's left is really clean JavaScript. It doesn't have any type checks at all. Traditionally, you kind of have to do those yourself, like you're saying, using type of checks or using some kind of reasoning where you're checking a parameter or a field, and then based on the value of that field, doing some bit of logic. So yeah, in some sense, there's some subset of those checks that can just be lifted straight into this optional type system, and then some of the performance gains of not having to do those checks at runtime kind of help you out. You do, in some sense, you will end up doing some checks, right? You can't lift everything into the static type system, kind of like I was alluding to before. Not everything is really easy to describe in a static type system. So what we kind of see is that there's kind of a balance. Just like the type system is optional, it kind of lets you jump in and jump out. A lot of the flexibility of using the type system means that you can put the checks in, and in some cases, by putting the check in, the compiler can look at it and say, oh, you're using a type of check. Now I know the body of that if has that type, and I can give you all the IntelliSense and error checking for that inside the body of the app. So it kind of mixes and matches.
Okay, so we're going to come back to that in a discussion of V8 further down, but I want to continue to give a better sense of the gains that you get from using TypeScript in your application development. So TypeScript was first developed because of shortcomings of JavaScript, which led to problems developing large-scale JavaScript applications within Microsoft. What types of problems were occurring in the application development process that TypeScript was developed to solve?
So back when we started working on TypeScript, we had teams like the Office team coming to us and saying, we have multiple teams working together on the same project. So basically, like multiple components, and we have to be able to agree on where these boundaries are, not just the boundaries, but like the contracts at those boundaries. And at the time, the only reasonable tool was the Google Closure compiler, which put, in comments, you could annotate the type information, and then the Google Closure compiler would check it. Being language designers, we kind of looked at it and said, well, ergonomically, it would be so much better if the types were kind of right beside the things that they were talking about, rather than kind of lifted out into comments. So that started the ball rolling of thinking, what we could do is build on JavaScript, a set of these kind of additional features that helped with these large-scale projects that needed types for being able to describe these contracts. And then that kind of grew from there. So those initial pressures meant that we also wanted to, something we haven't talked yet, is that the type system, in addition to being optional, letting you kind of opt into pieces, is also structural, meaning that it only cares about the structure of the type rather than the name. So for example, in a traditional language like C# or Java, if I say class C, and I write some stuff for class C, and then I say class D extends C, and then I start using a variable of type D later on, that's compatible with C because the names line up. Right? That's called nominal subtyping. What TypeScript does is says, oh my gosh, trying to keep all the names straight when you have multiple modules coming together, and that's very normal in JavaScript. For example, the promise libraries. You want something that's just, no. If it has the same structure, that's good enough. It has a structure of a promise. Anything that has a structure of a promise is compatible with anything else that has that structure. So that allows you this more what's called structural subtyping, so you can have the flexibility of mixing and matching. Again, kind of a theme for TypeScript, being able to do that with multiple JavaScript libraries and working together from that. So kind of popping back up to your question, having the flexibility and kind of building on that idea really helped us kind of define what TypeScript became so it could work with these larger applications.
Yeah, and I like the word ergonomic that you used to describe the necessity to move to not focus on ClojureScript, to focus on something that was better, that put the types right next to each other. And it seems like that idea of ergonomics is a theme when I've been researching and having conversations with people about this all JavaScript development that seems to have taken the development world by storm. It's not as much about using JavaScript stuff that performs something that is on a physics level, having some huge advantage. It's like the conversation you and I were having before this talk. I was interviewing a guy about Mongo, and it really seemed like the biggest performance gains that you get from Mongo are it's the same thing. It's like ergonomics. Everything is in JSON, and it just simplifies a lot of things for you. So yeah, I think that seems to be a theme in the new features of JavaScript development that have come around as of late. So how did Microsoft solve those problems before TypeScript? So did Microsoft just simply not do? I mean, I can't imagine they didn't do large scale web development. Did they just have incessant problems?
Yeah. So I want to get back to the ergonomics thing.
Oh, okay, sure.
Yeah, so let's.
Sure. So
let's loop.
Sure,
back.
we can loop that back.
All right,
that's fine.
Okay, let me answer what did we do before TypeScript? So before TypeScript, in fact, it's still being used in some places in the company. We use this thing called Script Sharp, which was a C# to JavaScript compiler. That's kind of cool, right? We already have a ton of institutional knowledge, especially at Microsoft, around C#. Great, let's just use that and compile it onto JavaScript. And we looked at that. We said, we could kind of build that into a thing and kind of put some more energy behind that. But when we actually started to think about JavaScript, if you could get close to JavaScript, so you're closer and closer to the language of JavaScript and the patterns of JavaScript, you're also getting closer and closer to what a VM can really rip on. And so if you're building these large applications, you're going to want smaller memory footprints and faster execution, and the best way to do that...
Wait, when you say a VM could rip on, you mean could have trouble with?
No, it could go really fast.
Oh, okay, I see.
Right, so it's just like when you're programming a game, you want to get as close to the metal as possible, right? So you want to be coding so that there's less abstraction. You want to get, fit the memory, fit the cache, fit the, number of threads and so forth. In the JavaScript world, you want to get as close to the patterns that the VM recognizes as possible, right? You'll be using less memory, and it'll be able to recognize it and then kind of turn that into faster VM code. So once we were one of the guys that was early on the TypeScript team is also one of the first engineers that worked on the Chakra engine. That's the JavaScript engine behind IE and Edge. And he was like, well, I can tell you what the good patterns are today. And we're like, great, let's start with those. So the class pattern and the kind of module patterns we were doing are all stuff that V8 and Chakra could really dig into and really make good, fast code out of. Once we knew we could do that, the path was really clear that JavaScript was absolutely the answer. And then TypeScript is really just kind of that little bit of extra for better tooling and error checking and stuff. Can we talk about ergonomics though?
We should totally talk about ergonomics. Dive in.
All right. So
is that like a buzzword around here?
No. Like, I was just thinking about like how much I care about ergonomics from a developer point of view. Think about like, and I'm kind of riffing on. Oh man, what is that guy's name? That I'll think about. We'll put like a link in the description or something. He was talking about the importance of shortening the time from when you get an idea to when you can output the results of that idea.
So like a cycle time?
Yeah, kind of like that.
Yeah.
Right? So if you have, not to pick on C++, I love C++, right? But man, the compile times are crazy. So if I have an idea, to know if that's even the right thing, I have to wait that whole compile time, right? Scripting languages knew to do this better. The turnaround time is so much faster. Great. So now I can just not compile and I can just kind of run it. And all the patterns that came out of that, like the Ruby days and Python and all the unit testing, kind of a huge birth of unit testing around that to get faster and faster. Right? You're trying to shorten the time between idea and execution and actually seeing the results come back to you. And so I think TypeScript, kind of bringing TypeScript into it, is trying to get wherever we can get that friction, kind of shortening the friction. If it's you're doing silly errors, sure, throw in some types. We can do an early check. If we stop you from doing that early error that you would have to debug anyways. If you don't want that thing to get in your way, great. If you don't even want a compile step, one of the things we just recently did was to add support to asm.js and some of the JSPM and that kind of stuff, so that you can just put a link in your web page and that will go and automatically compile your TypeScript. So you don't even have like that compilation step kind of, if you will, shortens a bit and you can just refresh your web page. So I think that I think one of the things that you were talking about with JavaScript before is that a lot of JavaScript developers care a lot about ergonomics. And I think that that's something we're trying to learn as much as we can and kind of incorporate into the design of the language and the tools.
Well, because it's like we're no longer developed by, or we're no longer bottlenecked by really processor speed. We're not bottlenecked by the amount of memory we have. We're not bottlenecked by cost anymore. What are we bottlenecked by? It's the fact that we can't talk to the computer like in an efficient enough fashion. So really all that we care about at this point, I mean, not all that we care about, certainly we want to fix those other things as well, but like the thing that we care about most, might as well speed up the developer time, because all this wasted developer time kind of sucks.
Yeah.
And that's what, and TypeScript solves a lot. TypeScript leads to an avoidance of technical debt and bugs and So assuming you've talked about ergonomics enough, I'm glad I piqued your interest with that. So something I found interesting, maybe this is like compilers 101, but so the current TypeScript compiler is written in TypeScript, which I heard talk where somebody said that, and I was like, well, so how was the first one? Like, this is like a chicken and egg problem. So obviously, like, this was the first TypeScript compiler was not written in TypeScript. So could you describe the process of compiler bootstrapping?
Sure. This is kind of like that age-old question. I remember when I was an undergrad, and it was a Microsoft talk. Actually, they go and buy pizzas and try to recruit their interns, and at the end, I totally had ignored the entire talk because they had mentioned compiler in the talk at one point. I was like, how does the compiler build a compiler? I don't understand. And so I walk up to the guy at the end. I'm like, I don't care what all you talked about. Just answer me this. What language was the compiler written in before it was the language the compiler wrote? So yeah, no. Oh man, good times. The original bootstraps of the compiler, I don't even remember what they're in. Probably like C# or something.
JavaScript.
Just to kind of get started. And then like there probably was a JavaScript version, and then it kind of
okay.
Like, right, so whatever was fast, whatever you could kind of write a quick parser and kind of output the code, we would do that and then kind of build quickly. right now I don't even think the compiler bootstraps itself because it already has the JavaScript version. You know, you got TypeScript, you compile that into JavaScript, boom, I just hand you the JavaScript and that runs everywhere.
Right. So to clarify, like I'm pretty sure the first TypeScript compiler was written in JavaScript. Maybe they just did a quick messy job, and then at that point they got your JavaScript compiler, and you can compile TypeScript to JavaScript, and then at that point you can write a new TypeScript compiler in TypeScript, compile that down to JavaScript, and then in the future you can use that for all your JavaScript needs and so on. Okay, so yeah, I thought that was interesting. I think the concept of compiler bootstrapping is interesting. I'm surprised I hadn't learned about it prior. So, how rapid is the adoption of TypeScript? Like how much? Because it seems like basically like why wouldn't you use TypeScript, right? So how fast is the adoption?
So when we first came out the door in 2012, I think it took a little while for people to try it. A lot of people at first were like, okay, the first thing was, wow, Microsoft and open source? No way. That's like a unicorn. It doesn't exist. But no, we kind of proved out that Microsoft could do open source. And it took us a while to kind of learn that. And as we were doing that, more people started trying the tool itself, started trying the compiler, started trying the editors that we were working on. And that started people talking to each other about, wait a second, this actually is not a bad idea. Once I start writing my JavaScript, I can kind of just use it when I want to, and I don't have to when I don't want to. And there is some little bit of there's some overhead to getting started, especially if you've got like a large project that's already in JavaScript. It does take you a little while to kind of bootstrap that whole thing up into TypeScript. Yeah, from the beginning we saw kind of this like linear growth, and now more recently as ES6 was really starting to take off, we did kind of a partnership with the Google Angular team. So Angular 2 is written on TypeScript, and now there's like about 5 big libraries that are written in TypeScript. That has started this, definitely an upward tick in things like NPM downloads, where we're seeing more and more people pick it up and say, this is actually a pretty good idea, and I can see where the value is.
I read a really good blog post, you probably read it, about Asana moving to TypeScript. So there are big entities that are adopting it. And the reason that Asana adopted were the same things that we mentioned earlier. They were just having all these problems in trying to iron out bugs in the development process, and I think they said it helped with testing too. So TypeScript was worked on heavily by Anders Hejlsberg, who is the lead architect of C#. So, and he also created Delphi and Turbo Pascal. So he's a legend in the development programming languages. Are there some language design preferences that he has that are common between these different languages that he's created?
Oh, that's a juicy one. Let me see if I can actually solve that in my head. It's like seeing the overlap of all these languages all at the same time. So one of the things that Anders has as an aesthetic goes back to Niklas Wirth, who's the guy that made Pascal. There's a simplicity, a kind of unifying aesthetic to how he designs languages. You can kind of you can see it especially kind of emerging as C# matured. At first it was like, oh, that's kind of similar to Java in a way. But as it's kind of matured, it's become its own thing, and it's got a whole bunch of cool features that simplify tasks like asynchronous programming or querying databases and objects and finding things in your project, like Lake, for example. So a lot of the aesthetic around keep it simple, be able to describe it. One of the things that he does really well is to go and talk to people. If you go watch his talks, they're really accessible. They're really well done. And he spends a lot of time thinking about designs that just translate really well. And I can describe it to you and you got it. You can just run with it. So I think that aesthetic has kind of carried through the years. And when he's applied that to JavaScript, It's kind of morphed and changed a bit, but it's still, I think, that underlying thing is still there.
Yeah, and he said in TypeScript, instead of a switch between typing or not, you have a dial. So you can turn up or turn down typing. What are some of the features that allow for a variable amount of typing from absolutely no typing to very explicit typing?
Sure. So when you first start using TypeScript, let's say you've got a JavaScript file already. You rename the JS to a TS, and then you run it through the compiler. The first thing the compiler is going to do is it's going to start doing some inference through your project. And the inference is local. It's not trying to do global inference, because that gives you some pretty crazy type errors. If you've ever used like an ML style language, you can get headache-inducing type errors. But locally, so you're looking at the code and you're like, I can squint at it, I know what's going on. Okay, that's good. Wherever it doesn't infer, like for example, let's say you've got a bunch of functions and you don't give any types for any of the parameters, we intentionally don't go diving because we want you to have nice local inference. So when you don't have those parameters, it's typed any. And the any type means anything's assignable to it, and from that I can assign to anything else. So it is a way of getting out of the type checker, like turning the type checker off. Anything that's of type any kind of gets out of the way of the type checker. So any concept, you can cast anything to any and then turn that type checking off. So really you've got nice fine-grained control using that feature in the compiler. The type inference, again, is local, so it's helpful, but doesn't try to get overly helpful and give you something confusing. And then kind of as you sweep that spectrum, there are features like on the high end, what I would say like the more strict side of TypeScript, where yes, inference goes, and wherever it can't infer something, it says that's type any. You can actually turn that off. So it's no longer allowed to ever infer type any. And then it gives you an error. So you can know if top to bottom, the compiler has understood absolutely every type in your application. And so that's called no implicit any. That's kind of like turning the dial all the way to 11 and then seeing everything that the compiler can see. And then forcing you to annotate everywhere it can't understand. At that extreme, you have like full fidelity knowledge of the whole application, and then you can do like refactoring, and any kind of refactoring then is safe if you're not using the any type. It's got the full static type information.
So with modules and generics and all the abstractions that you can build in TypeScript, JavaScript, you seem to be able to, within TypeScript, you seem to be able to reverse engineer Java's programming model or C#'s programming model, however you want to look at it. So a modern JavaScript application is written in TypeScript, it compiles down to JavaScript, and then it oftentimes runs on Node.js, which in turn is just running on the V8. So this seems really similar to Java compiling down to Java bytecode and running on the Java virtual machine, or C# bytecode running on the common language runtime. Is the future going to see JavaScript adopt an increasing number of Java features or C# features?
Yeah, I wonder if that's the case. So, with ES6, you've got classes and modules, like you were mentioning, and the kind of patterns that you can write in them now start to seem and look a little bit Java-like. And I think there's been, at least in the JavaScript community, there's been a little bit of backlash of, don't turn my JavaScript into just Java, right? They don't want it to kind of turn into the thing that they ran away from 10 years ago and, ran screaming. I think there's going to be some settling into the new patterns of ES6 as people start to use them. The libraries are being built today, your Ember 2 and Aurelia and Angular 2, like these kind of libraries that are like the modern libraries for JavaScript, and React also, like all of these use classes as like a main idea in the library. So I think it's probably going to settle that, yeah, JavaScript is going to keep maturing and evolving, and if you want to just keep using closures and functions, you can do that. But then there's still kind of a whole bunch of cool new patterns that if you kind of let yourself start to learn the ES6 stuff, kind of open the doors.
So if we start to look at raw JavaScript as an analog to bytecode, and it's pretty strange analog because you can read JavaScript, you can't really read bytecode.
Right.
But like TypeScript becomes relatively a higher level language, and you could conceivably, as we said, you can build Java or C# on top of JavaScript. And there's actually a project called Doppio that does this. If Java or C# represents the rich and highly developed extreme that we could potentially go to down this path, and the current version of TypeScript is the nascent, undeveloped extreme on the other side, where along the gradient between those two ends would you like to see TypeScript go?
Wow. The vision I have for TypeScript is to kind of ride along with JavaScript. I think with ES7, they're now entering like a yearly update. Like now, next year, this time next year, ES7 should be coming out. The following year, ES8. So JavaScript is going to start evolving a lot quicker than some of these, other projects, other languages. So that to me is in itself pretty exciting, that they're intentionally trying to speed up their evolution a bit, to kind of pull in, good practices from the community, turn it into things that are kind of codified in the language. TypeScript, being a superset, kind of happily rides along with that and can have the type checking and the type system and whatnot as part of that. That said, there is an effort that I'm working on with some of the other checkers like Facebook Flow and the Google Closure compiler to take the type system, like a common type system between us, and to standardize that into the JavaScript language. So you have this nice optional type system but that's fully supported in all the JavaScript tools and browsers and whatnot. And I think that is a really promising thing, but it's probably going to take some time to get to that point.
Google's AngularJS 2.0, as you said, was built on TypeScript. What was the process? And as I understand, the TypeScript team worked with Google on that.
That's right.
What was the process of partnering with Google like?
So it kind of started simply enough. We had a fan of TypeScript that was also worked on the Angular 2 team, Rob Eisenberg. This is last year, and he had been mentioning to them that TypeScript is there's some pretty decent guys on there that are interested in working with libraries. They're also interested in some of the features that Angular 2 was also interested in. So he kind of mentioned to them a few times that they should talk to us, and kind of mentioned to us we should talk to them. And so I think he gets some credit for us starting to talk to each other. Around November of last year, there's NG Europe. It's one of their big Angular conferences, and there they mentioned they announced this project called @script, and just like TypeScript is a superset of JavaScript, @set was a superset of TypeScript, and it had some reflection capabilities and some annotation capabilities, and we reached out to them and said, well, those are actually kind of cool. Would you like to work together and kind of bring @script and TypeScript together? So, from starting in November to, sometime in early March, we worked with them to fold the lion's share of those features from @script into TypeScript to the point where we were building the Angular 2 library as it was, back then. And we were showing them, like, look, we built the library, and then we built your demo, and now it's running. And that was with kind of the coordination with them and, kind of fixing stuff. And where we landed was something where they could start building all of Ingo 2 in TypeScript. And then I took some of that work that we were working on, which became the decorator proposal for ES7. Yehuda Katz had already been working on that. So he and I started championing this to the ECMAScript committee. So some of the work that we did is kind of like living on and hoping to become standardized as well.
I want to talk about the broader world of JavaScript. Why is JavaScript on the client and on the server such an important concept?
I think there's the kind of a sweet spot when we were talking before about ergonomics and reducing friction. Like if I can learn a bunch of patterns and I can get used to ways of working that works well with these libraries or works well with module systems and whatnot, I can translate that knowledge from the browser. A lot of that kind of carries over to the server. Now I don't have to learn a new language. With V8, the speed of JavaScript got so much faster. Like it opened up a whole new world of what JavaScript could be used for. And, props to the Google team behind that, because that really kind of lit the match under a whole bunch of, Firefox team and here at Microsoft, we started caring way more about JavaScript performance because now we see, wow, there's a lot that we can do. And since then, like all those engines have kind of jumped up and made really fast JavaScript possible.
Yeah, so to interrupt, I've been trying to figure out if I can get like a V8 expert to come on for this week, but I'm not sure I'll be able to. So is there, are you well versed enough in the V8? Could you give a technical explanation of nothing?
No, sadly not. Yeah.
Oh no. Okay.
So I have just a cursory understanding of the kinds of things that they did, but you would be so much better served having an engineer that worked on the team kind of give you a rundown.
Okay, but do you know, is this an accurate high-level explanation of what is so powerful about the V8? So prior to V8, you've got JavaScript and it gets converted down to bytecode, and then the bytecode has to get converted to machine code.
That's right.
And the power of V8 is that it compiles JavaScript directly to machine code and skips the bytecode intermediary step.
To my understanding, that's a piece of it. The other big piece is that they did a lot of work in detecting when a pattern of, before classes were in ES6, you had to encode a class into a closure, a function closure, right? So you have this function closure, and then it's creating the different fields and the different methods.
Is this prototyping that you're describing?
Yeah, like even before like having a prototype chain, having just the object and newing that function is going to stand up and then create a bunch of things dynamically, and then it's going to quit, right? So that function sounds awful lot like a constructor for an object. That's because it is, right? But you have to stare at it and see the pattern, recognize the pattern, and say, it's a constructor, right? That's an inheritance hierarchy, or that's a prototypal chain, or whatever, right? So I think some of the genius behind V8 and the way they work is they were looking at patterns like that and saying, I'm going to take a guess, and then if I'm wrong, then I'll fix it. And Firefox had been doing earlier stuff like that too. This is kind of evolution, right, rather than revolution, where we've been kind of like iterating. But you put a bunch of those ideas and you do it really efficiently, and then you come up with something that seems a whole lot better than where we were before. And I think that's really where they kicked it off.
Yeah, I find it interesting that JavaScript started as this thing that was just like this 3-day throwaway project, and now it's just become this giant ecosystem. Do you think that says anything about the broader picture of how innovation happens?
that we kind of put innovation in this weird.
Well, it's funny because like some innovations are like you work really hard at it, and like and then other ones are like just this total accident. Like it's like it's almost like some weird mutant evolution, because it's almost like it was random. Like Brendan Eich will even say, I didn't mean to do this.
Right. Yeah. Yeah. I don't know. I think that's probably like the question for the ages. Like, why does some technologies really take off? And it doesn't seem to matter a ton whether you invested, 100 hours or 10,000 hours, something connected to people that, didn't like explode,
Are there any big shortcomings of the current JavaScript ecosystem? Like, we talk about like, TypeScript, fixes the untyped problem, right? But are there any other pernicious, frequent problems within the area of just total JavaScript development that come to mind?
Well, one, now you got me thinking about bytecodes and stuff like that. Something that Brendan Eich just announced with this Web Assembly project that he's been working on. And JavaScript, like you said, it's like it goes everywhere. It's like it's in the browser, it's on the server. But one of the things is that it lacks certain capabilities that allow it to really be a target for like high performance applications like video games. Things like being able to do multi-threaded game engines, right? You can't really do that in JavaScript very easily. Being able to do SIMD instructions, SSE, MMX, that kind of stuff. That's just now starting to go in ES7, but hasn't been there, right? So you can't do like nice matrix math. And again, being able to do that in the hardware is what makes things like games look so awesome. You're doing all that optimization, where it is like laying on the metal. So some of the things that were like the domain of bare metal are now being lifted up into JavaScript. I think that is where you see them lifting in that kind of features is where the where the gaps were identified, the threading and the performance and whatnot. The WebAssembly project got started from this thing called asm.js, and asm.
It's asm.js.
That's right, asm.js. And the idea there, which was created by Mozilla, which was all right, we've got JavaScript. Let us narrow down the JavaScript language to a tiny subset. And that tiny subset, we know just enough about that to optimize the heck out of it.
It's like an instruction set.
Yeah, it's like a tiny instruction set that does only, for example, integer math, and you can do like an array, so you're manipulating things in an array. Well, shoot, if I know integers in an array, I can compile that down to just machine instruction codes trivially, and then just let the processor rip on that. And that asm.js project, they put that into Mozilla, the Firefox engine, and then showed off, some kind of like Unreal, like the Unreal video game engine. They show that running in the browser at like near full frame rates in their earlier demos, and it blew our minds because here's this thing that's it's basically just using WebGL and asm.js, and it's just you can run.
Is there a YouTube video of this? I need to put this in the show notes.
Yeah,
that sounds crazy.
You can find it.
I had no idea that was. Wow, that's nuts.
That's cool. Yeah, we'll find it after this. But yeah, it's cool, and the new demos are getting ever more increasingly crazy.
So is that just like, are they able to do that because they're like looking at a, how do they get it running so, is that just they know exactly what they're doing with this small sample?
Yeah, so the trick is actually that they don't write it themselves. They use this thing called mscripten, mscripten takes C++, runs it through the LLVM compiler toolchain, and then outputs JavaScript, outputs asm.js.
Oh, so they...
as its output. Right, so you have this
that's cheating.
Huge amount of JavaScript that's asm.js JavaScript, and then they just throw that at the browser, and the browser can run it. So it is kind of cheating.
Okay.
But now you have a way of they took their C++ source code and this 90% of it or whatever carries over to asm.js, and so their port times are like nominal by comparison.
But how can they reverse the process? Like, how can they go from seeing, oh, okay, we know now we know how to decompile essentially what they're doing, they're decompiling C++ code to JavaScript code, but the idea, as I understand, the idea of asm.js is to allow people to write or enable people to compile their JavaScript down to JavaScript code that runs a lot faster. So
asm is just the subset of JavaScript.
Okay.
So they are taking C++, going through the LLVM, and then outputting asm.js. They're not even trying to do JavaScript. So asm.js is just like the instruction set at that point.
Okay.
Right? So it's just they're converting the LLVM bytecode instruction set to
so what they're exemplifying is they're saying, hey, we've got this crazy C++ program and we figured out how to run it in the browser.
Yeah.
We can probably figure out how to run other things in the browser.
That's right.
That's fascinating. And so the collaboration for WebAssembly is pretty remarkable. You've got people from Chromium, people from WebKit, Microsoft Edge, which is the next iteration of Internet Explorer. Well, it's not Internet Explorer anymore, and then Mozilla Firefox. And so this is basically all the major web browsers teaming up to work on something. And so we were talking about this in the same conversation where we discussed, this is like AngularJS 2.0 being the collaborative result of Microsoft and Google. Are we moving into a world of technological collaboration among tech giants rather than like strict competition?
I hope so. I do.
Yeah.
I think there's like the thing that I want to happen more than almost anything, because it's so great to compete and come up with ideas and like, I can do that better, right? Do it. But then at some point stop and then collaborate with the other person and say, let's take those ideas and put them together. Because the end result, I'll tell you a story. When I first went went to TC39, which is the ECMAScript committee, it was 3 years ago or something. I was like, I don't get it. It's like everyone seems like they're going in a different direction. I've since sat on it, a dozen times or something. And I get it now. Like everyone's coming there with their own unique set of ideas, and they're all the overlap is minimal between the different areas that these people care about. But the end result is something that actually is quite cool. Like they're able to cover a huge swath of the kind of the engineering space around JavaScript. Some people care about security, some people care about performance. Someone like Yehuda cares about Ember and the way that you can describe what you want in JavaScript is it's more of the passionate engineer, the passionate artist. Each one has kind of their personality that they bring to it, and the combination is so cool. And I think that the more that we can kind of encourage that and show that works, I think the better off, honestly, that we can kind of get. It's still good to have competition. It's still good to have ideas kind of show which one should dominate. Something like React looking at Angular and saying, oh, I can do it better, and these are all the cool optimization techniques that we come up with, and we're gonna look at functional programming and all these new new to us functional programming techniques that were from a decade or 2 decades ago. We're gonna bring them forward and show the world that these are actually still really good ideas. Awesome, right? And then we see that idea kind of percolate into Ember and Angular, and other libraries see that and say, yes, immutable data structures are fantastic, or minimal change detection, fast change detection algorithms are great. Thank you. And now they've got something that feels a little bit more collaborative, and they can kind of share these ideas.
Yeah, it almost seems like there's enough of the pie to go around. There's not really a need to compete if it's this gigantic pie. We're all gonna win, assuming the world doesn't collapse. I don't know. Anyway, so getting back to TypeScript. So This question may not really be relevant, but how does the speed of TypeScript interpretation compare to JavaScript compilation on the VM? Or sorry, on V8?
That's the speed of TypeScript compilation. So the TypeScript compiler does a number of steps, so it's hard for me to kind of like mentally pull apart the different stages. So, and maybe it's kind of, since this is a more of a technical deep dive kind of podcast, maybe it's kind of cool to talk about what those stages are.
Sure.
So people can kind of mentally see that.
Please do.
So the first stage in the compiler is...
So this is a piece of TypeScript code, You've written it, you're getting ready to compile it down to JavaScript.
Right, so you call the compiler and you pass it that file. The first thing it does is what's called parsing. It's going to take that file and then it's going to turn it from just being straight line text in a file to being a tree. And that tree, kind of like, remember sentence diagramming back when you were a kid? Right, it's kind of like sentence diagramming. You've got, all right, here's the start of a statement, and then the statement is broken into, let's say, an assignment statement. All right, there's an equal sign, and there's a left-hand side.
So it's abstract syntax tree?
Right, okay. AST. So this abstract syntax tree has some cool features that we need. For example, we try to maintain white space, and we try to maintain some of the comments that you're putting in so we can put them out of the result. So it's not completely abstract, but it's abstract in that, yes, we know your whole file as this abstract tree. It goes through kind of a sanity check. The next thing it does is it goes and tries to find where each symbol is declared. So I'm using X down here, and then the var X is way up at the top of this function. Great, it's going to do this binding phase, and it binds all these variables and binds all the symbols. Once it's bound everything, it knows where everything's coming from. It does a full type checking. The type checker and the parser are meant to be able to work on the command line. So just like every other compiler ever, you can kind of run the file and it goes top to bottom and does it. But they're also made to work in an editor. So I can be inside the file and I can be typing in, inside of a function, and the parser is able to kind of locally reparse that section rather than having to reparse everything. Right, so now I can do really large files in my IDE really quickly because I've got this nice incremental parsing. The type checker also is meant to be able to kind of reach into the tree and then start at this part in the, I might be deep in the tree. I grab that node and say, what is your type? And it can go and calculate it, and it goes back up the tree as far as it has to and then stops. Takes that whole path and says, oh, there's your type, and then hands you the type. So it doesn't even have to calculate everything to find the type of one little area. It can do it more kind of pull or lazily. So these features allow you to work both as a command line compiler and as an IDE or editor style kind of language service. So you do a full type check. When you have a full type check done, then you can emit. And then we just kind of, just like you imagine, it's just going to run through that tree. It's going to try to carry as much of the white space and comments through, and then it outputs really clean JavaScript on the outside because we've kind of carried that all the way through.
So where I was going with the speed of TypeScript interpretation versus speed of JavaScript compilation, I was curious, is there a vision for, or maybe you can already do this. This is probably something I should have checked out first, but this shows the difference of preparing for a podcast versus actually learning how this technology works. But can you write TypeScript in the browser?
Yeah, so there's a couple ways to do it. I kind of mentioned really early in the podcast, there's a module loader called system.js. System allows you to kind of hook up a transpiler. So we're going to run through, see the TypeScript, compile that, and then run that. So you can do that in the browser. The TypeScript playground, which you should go to if you want to check it out.
That I tried out.
Computer, right? So there's TypeScript.
I guess that should have answered my question. Yeah.
Yeah, TypeScriptlang.org/playground. You can go to that, and the entire TypeScript compiler is being hosted in the browser at that point. So as you're writing on the left-hand side, you're seeing the live output of that compiler on the right-hand side.
Sure. Yeah, that makes sense. Are there some best practices for migrating a JavaScript application to TypeScript? Has anybody written a book or an article on, here's how you do it?
There's a couple ways to do it, and I think different projects are going to have ways that work better for them. The project that kind of became Visual Studio Online early on had about 200,000 lines of JavaScript that they had wrote by hand. They did a ton of unit tests. There's a blog post about this. Instead of moving it one file at a time, they took the whole thing and just renamed all the files, and then took 2 weeks. Boom, there's your 200,000 line TypeScript project. And they put just enough type information there that the TypeScript compiler, where it couldn't figure things out, it could kind of get a little bit of help. So you can do it that way, and then now you have something that's very, very JavaScripty with just a little bit of types, and then over time you can kind of use more and more TypeScript features if you want to. So that's one style. It's like the big bang approach. There's kind of more of an incremental approach where people can take, you've got a large project, I take a single JavaScript file, I rename that to TS, and then in my build step, which I might have if I'm doing magnification or something, I take that TypeScript file, I compile that to JavaScript, and then the rest of it just kind of carries through just like it was before. So you can do that kind of incrementally. You start with a single file, and then you might add a couple more, and then a couple more. So the TypeScript playground is actually from this project called Monaco. It's the same project that Visual Studio Code is built out of. And that was, initially done very incrementally. Only 1 or 2 people on the team were working in TypeScript. They only did 1 or 2 files just to try it out. And I guess funny story about the Monaco team is they weren't even bought in about TypeScript. They weren't even sure that was a good idea. So they were early on, they were trying it out. And when a couple people on the team, one person on the team tried it, showed the other person, they're like, oh, that's kind of cool. Then they started using it, and then it kind of organically grew through the code base, so that by the end, it was 100% TypeScript, but that took over a year of them kind of moving more and more and more stuff into TypeScript. And you can kind of do it that way and kind of create a frontier that you're moving.
What was the so you were the program manager for this project?
That's right.
So what was the process like? So from the very inception, you were the program manager, or from when it started, or?
So when early days, it started. One of the other TC39 members, Luke Hoban, was the program manager, and I was kind of, if you will, mentoring under him. So the two of us were kind of the PMs over the TypeScript project. About 6 months to a year, I can't remember exactly when, he moved off of doing JavaScript and moved on to be do other projects, and then after that I kind of became the program manager.
So what was how do you manage how do you manage a process, a program? How do you manage the project of building something as complicated as a superset of JavaScript? I mean, I can think of how do you manage a project for a to-do list application, or a shopping application or something, but this is much more abstract, right? So, what's the planning process? And
I have 2 really good dev leads that work on the team, and we do the planning cycles and all of that. Everyone is lockstep together. So I work with the dev leads. They're doing the projections and the bug burn downs, all the stuff that you need a dev lead or dev manager to do. And then my job as the program manager is basically to say, how healthy is the project? Where are ways that we can kind of grow the project so that it's a little bit stronger? What are partners that we can partner with, like the Angular team? That was kind of my responsibility to kind of continue that. And really continuing to look where the community can grow around it. So the day-to-day stuff I do some of, but mostly what I do is the high-level thinking and planning and making sure we're going the right way.
Great. All right. Well, it's been great talking to you. Again, Jon Turner maintains he's the program manager for the TypeScript project at Microsoft. Jon, thanks so much for coming out to Software Engineering Daily.
Thanks, Jeff. It's been fun.
Yeah. Awesome. That was sweet. Really enjoyed that.